In this video, we explore how we can actually find the minimum point or the vertex from a factored form given a quadratic formula that we have managed to factorize. Let's look at it. What is the vertex of a curve or quadratic equation? Simply put, it's the highest point or maximum. It can also be the minimum. It's the top of the mountain or the apex. Think about geometrical shapes and vertices. Vertices are the edges, and so this is what we're looking at here. In this curve, y equals x squared minus 5x minus 6, we see that at 2.5, negative 12.25, there is a lowest point, a minimum for the curve. This is because the quadratic is facing up. If the quadratic was facing down, there could be a maximum value. And in this case, we say the vertex of this curve is at 2.5, negative 12.25. How do we find a vertex then from a factorized form? Now, there are many ways to find a vertex, but let's remember that parabolas are symmetrical shapes. And if you found a factored form, typically speaking, you found the two solutions. So if we look at this shape here, you'll notice that if we were to draw a line in the middle, that goes exactly through that bottom bit, which is the vertex. So that's quite handy. And you'll notice also that it's exactly in between the two solutions. So you have your first intersection with the x-axis on the right, you have your second intersection with the x-axis on the left, and if you were to go exactly in between, right down there, you have the x-coordinate of the minimum point. There's the minimum point. So the minimum value is in between the two solutions. And if we take the same concept which we just looked at and apply it numerically, looking at this example here, so let's draw a line through the middle. On the left, we have x equal negative 1, which crosses the x-axis. And on the right, we have x equals 6, which crosses the x-axis. What is the value that's exactly in between negative 1 and 6? Well, you can take the average of negative 1 and 6. If you were to add them together and divide by 2, negative 1 plus 6 is 5, and 5 divided by 2 is 2.5. And sure enough, that's exactly the x-coordinate for which this curve reaches a minimum point. It's not the y value of the minimum, it's the x value. For which horizontal value are we reaching that? It's not telling you how deep the minimum point is. It's just saying it occurs at 2.5. Now, if you wanted to find the y value, you'd probably have to plug that 2.5 back into your equation, because remember, an equation is a collection of points. You plug in x values, they go through transformations, and you get y values. And this is what we're going to learn how to do here. Let's find the coordinates of a vertex. We're going to put our knowledge to good use and find the middle of those two x-intercept. And remember, when we say coordinates, we mean both the x and the y values. Here's a quadratic, which is x minus 1 times x plus 3. You'll notice that it crosses at negative 3, 0 and at 1, 0. And at this point, you can ask yourself, okay, so these are the two solutions, negative 3 and 1. What is the midpoint of negative 3 and 1? What's the average of those two numbers? To find the average of two numbers, we can add them together and divide by 2. Let's do that. Let's do negative 3 plus 1 divided by 2. So that's the formula for your average. Add the two numbers and divide by 2. So if I do 1 plus negative 3 divided by 2, I end up with negative 2 divided by 2, which is negative 1. And as you can see, the value of our minimum is at negative 1. Negative 1 is exactly between negative 3 and 1. But that's just the x-coordinate. And we need the y-coordinate as well. Well, to find the y-coordinate, we're lucky. We have this equation, y equals x minus 1, factor of x plus 3. If we were to put in x values, we will get y values. So if we put the x value negative 1, we will get a y value for that x-coordinate. We can do that right now, since we need y as well. Let's try y of negative 1. That means we're trying to assess how high or low that point is, and luckily enough, we can do that by plugging it to the function. So negative 1 minus 1, factor of negative 1 plus 3, which will give you negative 1 minus 1 is negative 2, factor of negative 1 plus 3, which is 2, and negative 2 times 2 is negative 4. Now, negative 4 is the y-coordinate of your minimum point. That means this function reaches its lowest point at x equals negative 1, y equals negative 4. And that is the minimum point, which the green arrow is pointing to now. Let's find another vertex. I hope this was not too hard. I think that if you do a couple of them and you really realize that it's in between the two x values, you should be fine. Just need to practice. So remember, we need to find the x and the y coordinates for those vertex values. And so here is a new quadratic equation, x minus 2 times x minus 6. It crosses the x-axis at 2 and at 6. Let's ask ourselves here, what is between 2 and 6? We can see visually that the number between 2 and 6 is 4. If you couldn't see it, you could always do 2 plus 6 divided by 2. So the equation for the average is that you add the two numbers and you divide by 2. So for the minimum value, you have 2 plus 6 divided by 2, which is indeed 8 divided by 2, and that is 4. Now 4 is the x-coordinate of your minimum. Remember, we want the y-coordinate as well, so that we have the actual location on the map of that point. Now we can see here that the y-coordinate is negative 4, but if you couldn't see it, you can always plug it into your equation. Y equals x minus 2 factor of x minus 6 will generate points. Any x value you plug in, it'll give you the y value for it. So let's plug 4 in there, and that's pretty straightforward. Y of 4 is equal to 4 minus 2 times 4 minus 6. And 4 minus 2 is 2. 4 minus 6 is negative 2. 2 times negative 2 is indeed negative 4. And that's the coordinate of your minimum. So your minimum point is at 4, negative 4. There you go, and the green arrow is pointing to it. This is how you find the coordinates of a vertex using factored form. We'll look at some other ways to find the coordinates of the vertex. Please like and subscribe. See you on the next video. Goodbye.